Welcome back to another segment of the Digital Forensics series. In this segment, we'll look at MBR analysis, that's Master Boot Record Analysis. A few reasons you may want to perform MBR analysis are so that you can verify how many partitions there are on the disk, verify the attributes of the partitions. This could be information such as size, disk format, and starting cluster of the data areas. By verifying this information, we can then start asking questions such as, are there any abnormalities with the MBR? Are all the existing partitions accounted for? Or are there any hidden unfamiliar partitions that we can't see? And keep in mind that some partitions are hidden by the operating system, and by performing MBR analysis, we can conclude that those partitions could potentially be excluded from the investigation, but it pays to still check inside those partitions for any anomalies. So let's start by analyzing this MBR that I've retrieved from the internet on my right hand side. There will be links in the description below for all the information that I've used in the segment. I have a MBR cheat sheet that I'm using against the MBR that we're analyzing. This will help with understanding what bytes represent what information. When you first look at an MBR, it won't make any sense, but by using the methods outlined in this segment, you should be able to analyze any MBR. Now, I won't cover every single bit of information. I will only cover particular parts that I've chosen to be of interest, and these are pretty common bits of information that I'll be explaining anyway, and this should be enough for analyzing major situations that may arise in a forensic instance. And a few things before we begin. So an MBR can only have 4 partitions. An MBR ends with a 55AA magic number. We use this to identify where the MBR ends, where the last partition information is, and from there we can identify the other 3 partitions. So let's begin with the partition, the MBR on the right hand side. I'm just going to use snipping tool to crop this out so it's easier. So I've retrieved this MBR from the internet, and you've got to understand a few things before we begin. This MBR's view, the layout, whoever cropped this image out, the layout of this is 16 bytes per row. 2, 4, 6, 8, 10, 12, 14, 16. 16 bytes per row. 2 hexadecimal numbers represent 1 byte. So that's what we want, because this template that we are going to be using, which is provided by this person, and you can find it at this website. Well, I'll also leave all these tabs of information in the description below so that you can access it when you're performing your analysis. So we use this 16 byte per row layout against that template, against our MBR that we've got from the internet, or whatever MBR that you have, that you would have opened up in hex editor and you would have retrieved from the forensic disk that you've been provided to analyze. So we know that the magic number which ends in an MBR is 55AA. Luckily, that's where this particular MBR cuts off. So it's quite easy to analyze where the last partition is, and it's also easy because this is 16 bytes per row. So let's just begin. So the last partition on this particular MBR is over here. We don't count the 55AA, that's the magic number for the end of the MBR. And the third partition is the teal color over here. The second is the yellow, and the first is the other bluish greenish color. So the information that I'm going to be extracting from these partitions are the boot indicator, which will give us an indication of if this is a bootable or a non-bootable partition. The system ID, which is a type of partition, so if it's a FAT16, FAT12, FAT32, NTFS, HPFS, etc. I'm going to also extract the starting LB address, which is the relative sectors. And the reason for this is because in future segments I will make videos on fat file carving. So this particular bit of information, the starting RB address and the size of the sector, the total size, will help us find the data area and find how big these particular files are. And by getting used to this particular analysis type, we'll be later on, we'll be able to successfully carve out fat file systems, disks that have been corrupted, and we'll be able to retrieve data in later segments. So by doing this in these segments, these early segments, it'll become a lot easier and a lot familiar. So we'll be getting the starting LBA, which is the relative sectors, and then we'll also be getting the total sectors, which is the size of each partition, just to get a rough idea. So let's begin by the first partition. So the boot indicator is in that byte. So the boot indicator for this one is 00. And by the cheat sheet that we can see, that 00 is a non-bootable partition. I'm just going to write that down. So 0. And when you're writing hexadecimal numbers, you always want to put a 0x in front of the actual number, because it represents and it differentiates that particular digit by a decimal as opposed to a hexadecimal, and it's easier for you to read if you get into the habit. So 00 equals non-bootable, and the type system ID is in this particular byte. So the third byte, even though it's a second because we start from 0, the third byte, luckily someone's already selected this for us, is 0C. And what is 0C? 0x 0C is FAT32 LBA. That's the common partition values. That's the FAT32 LBA over there. So FAT32 logical block address. And starting sectors, relative sectors starting LBA address is not that one. I've highlighted that just for referencing so I can easily see this next one. So once I've highlighted these, I can highlight the next 4 coming from here, so it's easier for me to read. I'm making this as easy as possible. But otherwise, if you find it applying this template directly down, and if you find it comfortable counting this way, that's completely fine as well. I just found the last 2 bytes here, and then I just went to the left hand side because that'll be the second partition information. So I just went to the left hand side that way. And when you're reading more than 1 byte from this hex editor, you have to read it in Little Indian. And the way that's done is you read from right to left in each byte column, but then you read left to right in the entire array of the bytes you are reading. So for this particular one, humans, we're practically programmed to read 3F. Well, people who understand and study in English, English oriented countries would read from left to right. So we'd read 3F 000000. But that's not how the systems read it. The systems will read it 00000003F. 0x 00000003F. And because in normal mathematics, all the zeros that are before, you can just delete because they don't change the value of the final result. So that is the relative sectors. And then again in Little Indian, so we're going to take 003B 90 F4. Just going to double check that 003B 90 F4, and we will take out the starting zeros. That's the bit of information. So the starting LBA, we're going to take 3F, which in decimal F is 63. And then we'll move on to the size. So the size is 3B90F4. Well, 3B90F4 is in decimal, that value there. And because the MBR is in 512 byte sectors, if we multiply this value by 512, we will get the actual representing value that we'll understand a bit more. So we take this value, multiply by 512, gives us that much, and that again is in bytes. Okay, so we can use something like the Google calculator, which converts bytes to gigabytes. Make sure it's not in gigabytes, that's a different measurement. Take gigabytes, paste that value, and you can see that it's roughly 2 gigabytes, that particular partition, which is roughly 2 gigabytes. So that's the first partition done. And let's move on to the next partition now. So partition 2 is, that's the value. I will erase this so it's a little bit easier for us to see. Cool. So the second partition is there, and we want that information. And then we also want those 4 bits there, bytes, sorry, and then those 4 bytes. Cool, so I'll fill out this table. So the boot indicator is 0x00 again, and the type is 0x1c. The starting LBA and little endian is 0x. I'm not going to include the starting zeros if there's any, or actually I will, just so it's easier, but I think you'll pick it up by the end of the segment if the more we do it. By the time we get through 4 partitions, it should be quite familiar. So 00, 3B, 91, 33, and then the total sectors, which is the size, 0x00, 3B, 91, 33. Am I seeing things, or is that the same? No, I'm not seeing things. That is exactly the same, which cuts a little bit of work down for us. So we know again that this is non-bootable. And what is 1C? 1C is not visible to us on this chart, and because of that reason I have more partition table types over here. So I'm just going to look for 1C and see what that is. There's 2 found. No, there's 1CH. Okay, I have a tab, partition, which I haven't opened, but I can't seem to find it. Common partition values. Okay, we can use this. 1C. Wow, I found 34. Okay. There we go. So this is a FAT16 volume using this particular website there. This is a FAT16 volume, and 1C is a hidden sector, the number of sectors on this volume before the boot sector. The number of sectors on this volume before the boot sector. This value is used during the boot sequence to calculate the absolute offset of the root directory and data areas. So we only need to know the type for now, but that's very useful information. 0x1c. So if we go back, that's a FAT16 volume. FAT16. And The next relative sectors calculation is 3B9133, and decimal is that 3993795. Cool. And if we do that multiplied by 512 byte sectors, it's that much. We can take this value and chuck it in the Google calculator. It's roughly the same again, so roughly 2 gigabytes again. I just want to see if I've done the right one. 3B9133, yep. So it's roughly the same value again, so that's which equals 2 GB. Cool, so that's the information for partition 2. So now let's extract partition 3. Partition 3 information is just there, so that there. Okay, so 0x00 again, non-bootable. 0x06. What is 06? It's a FAT16B type partition. Then 0x00772266. We'll take out the starting zeros. 0x00017886. Take out the starting zeros. So partition 3 is non-bootable again, and 0x0c is, sorry, 6 is a FAT16B. Then the value of the starting size is 772266. That's the decimal figure of the relative sectors, which is the starting LBA address. And 178.886 multiplied by 512 byte sectors, which equals that much. Which is roughly 0.05 of a gigabyte. 0.05 of a gigabyte. Cool. And partition 4 now. That, and there. So the boot indicator is 00. The system ID is 0x0b. The relative sectors is 0x00789AEC. The size 0x006E 2514. And we'll take out the starting zeros. And we know that again, so 00 is non-bootable. 0x0b is a FAT32CHS. I'm looking at this table here, the common partition values, and if I can't find it in this particular one that's provided here, which are the most common ones, you can use that particular website or that website and it will show you more in-depth partition values. So the starting LBA relative sectors is 789 AEC. That's that in decimal. And then 789 AEC. So 6E2514. See decimal value there. So multiplied by 512 byte sectors, which then equals that much, which in turn equals 3.70. So roughly 3.70 GB. Cool. So from just with that template, I hope this particular segment helped you. So I've used that template against this MBR, and we know that MBRs only have 4 partitions. We've extracted the information that I thought was very relevant, because this will help in later segments where you can use this information to carve out files, and that's what I'll get to eventually in the future. And I wanted to help you guys to kind of get the analysis of just the MBR at this stage, and you can see just by those 4 sections we've gotten a lot of information. We know that, hey, look, there's 4 partitions, 2 of them are consisting 2 gigs, and one is over 3, and one is just under a gig. Sorry, 0.05 of a gig, and we could analyze these very fast if we needed to in a forensic instance. I hope you like this segment. Subscribe, give this video a like if it helped, and yeah, I guess you'll see more videos like this, and eventually the fat file carving, which is quite interesting. It's a lengthy one, but it will be interesting, because the first time I had done it, it was very interesting. Because I thought once you delete something, it was deleted, but apparently that's not the case. Hey, thank you guys for watching. Like, comment, subscribe. All the links will be in the description below, and yeah, keep an eye out for more segments of digital forensics.